Hello everyone, we are group 16 and my teammates are Arvind Nagireddy, Sai Manoj and myself Sai Pranavi, and our topic for today is bypassing biometric systems with 3D printing and enhanced grease attacks. Throughout the history of humanity, every restricted access has been determined by knowing or having a certain entity that proves that permission must be granted. Passwords are something that a person knows, while tokens are something that a person possesses. The years has passed, and researchers have encountered several shortcomings regarding the traditional authentication system that represents the most frequently used approach nowadays, leading to the adoption of new alternatives. In 1971, A.J. Goldston, L.D. Harmon, A.B. Lex published the first paper that describes how human faces can be identified by humans and by computers. These studies from a foundation for counting researchers on a real-time man-machine interaction for computer classification and identification of multi-dimensional vectors specified by noisy components. The encounter between biometrics and computers created a new path for authentication systems in the following years. Biometrics is the use of person's unique behavioral and morphological characteristics to provide positive personal identification. Biometric authentication systems are pattern recognition systems that read biometric data as input, extract a feature set from such data, and finally compare it with a template set stored in database. If the extracted feature set from the given input is matched to a template set stored in the database and the attempt limit is not exceeded, then the user is granted. It is very important to understand in which ways biometric systems may be exploited. Every biometric system is made up of the parts. Those are scanner, feature extraction, store templates, matcher, application device. The scanner module in a biometric system is used to acquire biometric data like fingerprint, hand vein, palm print, voice, etc. of an individual in the form of an image, video, audio, or some other signal. Feature extraction. It's a module in a biometric system which operates on the signal sent by the scanner module to extract a feature, for it be a set A, that represents the given signal. The extracted feature, which is set A, is sent to the matcher for processing. Stored templates, they usually are a database that stores pre-acquired, usually during the user's enrollment, feature sets called templates. These templates are queried by the matcher module to find a match for the given feature. Each of the parts are vulnerable to some type of attack, which I'll explain in the further slides. The matcher is the most important module because it receives a feature set from the feature extractor module and it compares those with the templates stored in database. Match scores are generated after each comparison, and once all the comparisons are done, the matcher processes these match scores and it determines whether the identity of an individual is authentic or not. The application device, it receives a Boolean answer from the matcher and acts accordingly, denying or granting the access. This is the biometric system flowchart. As you can see, the biometric sensors takes the signals from any individual and the feature extraction extracts those signals from biometric sensors and stores them in stored templates. When the matcher checks the authenticity, if it matches, then it's a success. If not, the user again has to pass on the biometric sensors and then the process is repeated until the matcher can take it as a success. If not, it's totally discarded. Types of attacks. We have 9 types of attacks that are possible. Let me quickly go through them. Type 1. In this attack, a fake biometric trait can be created. Type 2. In this attack, the communication channel between the scanner and the feature extraction is intercepted to steal the biometric traits and it's stored somewhere. The attacker can then replay the stolen biometric traits to the feature extractor to bypass the scanner. Type 3, in this attack, the feature extractor module can be replaced with a malicious one. Type 4, this attack is similar to type 2. The main difference is that attacker intercepts the communication channel between the feature extractor and the matcher to steal the values of a legitimate user and then replay to them later. Type 5, this attack is similar to type 3. The main difference is that the attacker replaces the matcher with a malicious one. Type 6, this attack compromises the security of the database. Type 7, this attack is similar to the attack of type 2. The main difference is that attacker intercepts the channel between communication and database. Type 8, the attacker intercepts the communication channel between the matcher and the application. Type 9, this attack is not focused in the biometric system itself but in the application that handles the authentication. As you can see on the right hand down corner, in the process, at what point of time each type of attack is highly possible. So all the 9 types of attacks have their own positioning. That's the reason even many of the attacks are similar to the ones before. They can be repeated in the other phases with the same with a little bit of distractions. So now Sai Manoj will take over. Thank you.
Hello everyone, my name is Manoj and I'll continue with the presentation. Coming to the fingerprint biometric systems. The fingerprint is the most accepted worldwide biometric among all the others. We can see them almost in every device on regular basis because it is easier to achieve technically with less cost. Face recognition system is significantly higher and needs higher precision to achieve. Due to the worldwide acceptance of fingerprints, the cost to make these devices has been reduced. There are 3 different types of fingerprint scanners, and the first one is optical fingerprint scanners. These scanners work on the principle of charge-coupled device. It is a light-sensitive device that captures all the images of the fingerprint. It will convert those photons to electrons and then later to pixels. The fingerprint accuracy is dependent on the amount of light passing through it. If the light couldn't capture enough pixels of a finger, then it might have higher false negative values. People having sweaty fingers will not be recognized on these devices. And the second one is capacitive fingerprint scanners. These are the most used scanners when fingerprints were started on smart devices. Capacitive scanners were used on smartphones, tablets, and etc. Instead of light sensors, these scanners use capacitor or conductor circuits. These circuits charge up the capacitor plates which collect all the data. All the changes and readings are converted from analog to digital. We have to make sure that we use the whole finger, which will be stored for authentication at later dates. One of the best advantages of the scanner is that it cannot be fooled by an image. Even using prosthetics cannot fool these scanners majority of the time because of the different charges in the capacitor for different changes. Because of that high density, it will cost a lot of capacitors to scan. And the last one is ultrasonic fingerprint scanners. These are the latest fingerprint scanners that are being used nowadays. These were started in 2016. To capture these fingerprints, the devices should have an ultrasound transmitter and a receiver. So the transmitter will transmit the ultrasonic waves to the scanner where the fingerprint is. The waves will bounce back from the fingerprint depending on the ridges and the pores. The sensor that captures the written data detects the stress and calculates intensity according to it. These scanners are usually found on the phone screen itself. So there was a problem because of the screen protectors which made the scanners less accurate. Now coming to the fingerprint biometric system attacks. Grease attacks. This attack is performed by having a clear grease stain left on the surface of the fingerprint scanner. After the original user uses the scanner, his fingerprint characteristics should be left behind on the scanner so that it can be used for further purposes. The only problem is that all the key characteristics unique to that fingerprint should be captured on that grease. We have four types of attacks. The first one is gummy bear. This candy has a similar texture to the fingerprint, so by placing it gently on the scanner grease on it will help to retrieve the characteristics of the fingerprint. And the second one is silicone fingerprints. These silicone tips have a similar feature to a finger like the gummy bear experiment. Place it gently on the scanner will help us to retrieve the fingerprint. And the third one is latex glove. The latex gloves have a greasy and rubber texture to it, so by wearing a latex glove and applying equal pressure on all sides on the scanner will help us retrieve a fingerprint. And the last one is a Play-Doh. This toy has the most amount of greasy and sticky nature. It is very soft to nature and can absorb even the tiniest particles, so placing it on the fingerprint scanner and applying gentle pressure can help us retrieve fingerprints. Because of its nature, we must store it in a safe place. In coming to the results of these grease attacks, the attacks that we have done above did not fool any of the capacitive or ultrasonic fingerprint scanners. Now coming to the advanced grease attacks, as we have seen that the grease attacks could not fool the fingerprint sensors. It is because of the complexity of the sensors. So we researched a few more techniques that can hopefully fool these sensors. We have four types of advanced grease attacks. The first one is moisturizer. In this method, we use moisturizer to enhance the marks on the sensor. The original user has to use the sensor after that, so it will have a fresh fingerprint marks on it. Later, we can use the latex glove to retrieve the fingerprints. And the second one is petroleum jelly. It is similar to the moisturizer. We must apply this on the sensor pad before the original users use the sensor. This will help to enhance the stain so that we can use a silicone tip later to extract the fingerprint. And the third one is paraffin. Similar to the previous methods, we have to spread this ointment over the sensor board and wait for the user to use the fingerprint sensor. And the last one is lip balm. In this method, we can use a lip balm to enhance the fingerprints. We wait for the user to use the sensor and use silicone finger tip or the latex glove to extract the fingerprint. In, in coming to the results of these advanced grease attacks, hand moisturizer did not break both the capacitor or ultrasonic sensors, but petroleum gel, paraffin, and lip balm were able to fool the capacitive sensor but not the ultrasonic sensor. None of the experiments were able to break the ultrasonic sensor. So that's it for my part, and now my friend Arvind will continue with the presentation. Thank you.
Thank you, Manoj. Now I'll be talking about consensual attacks. So, consensual refers to a situation in which the user whose biometrics we are collecting is conscious of the procedure and voluntarily engages by pushing his fingers into a mold. Although we have categorized this method, there are not many approaches to accomplish the same goal that could be desired as consensual. For instance, one can record a human fingertip while they are sleeping or use social manipulation strategies to trick a victim into disclosing an impression. There are numerous ways to accomplish this, but only a small number of them can be carried out in a fashion that the victim is unaware of. So we have created some finger molds by using Play-Doh. The very first attempt involved using a mold made of plasticine. Before pressing the fingertip into the Play-Doh to construct the mold, it was blended for a bit to make it malleable and easier to mold. To get a nice mold, you must push your finger solidly against the Play-Doh for several moments. And next, we used candle wax. As the following attempt, we we attempted hot wax as a mold. All the wax was liquefied and some of the melted wax was placed in an aluminum foil where we gave it some time to dry before pressing our fingers on the wax. And the next substance we used was hot glue. The final mold was extruded from a glue gun into a sheet of aluminum foil where it chilled slightly. After dipping our fingers in the liquid, we placed it against the hot glue for just a short period of time, and the adhesive was useful once it was dried off. Unconsensual attacks. These assaults do not consider involving the user, and dormant biometrics are collected in an uncooperative manner. The process from finding a latent fingerprint to getting the fingerprints recreated artificially is not simple. First and foremost, it is difficult to tell which finger is the right one. It would be ineffective to try to lift a doormat fingerprint from a finger that is not used in a fingerprint verification system. Several techniques for getting it were given, some of which we have already discussed in our research, presuming that the right doormat fingerprint has been indeed found. Digital camera. The Samsung Galaxy S10 device video camera that can capture photos up to 12 megapixels in scale was used as our first attempt at fingerprint digitizing. It was crucial to be able to approach the fingerprints closely enough just to capture a complete image. Getting clear, in-focus pictures of small subjects was made feasible by the camera's convenient macro feature. Transparent tape. This technique primarily works on fingerprints that have been dusted. We can remove this laser-toned dust that had adhered at the latent fingerprint by employing a white translucent tape. Results: hot glue produced the best outcomes for the molds, and liquid latex and wood glue produced the best outcomes for the casting. We were able to trick all the detectors using a hot glue mold and a wood glue casting, and we achieved the same results using an alginate mold and a liquid latex casting. We attempted a number of combinations of gelatin powder, water, and glycerin to manufacture Belastin gelatin at home. However, the outputs were inefficient to trick the scanners. The false prints are so tiny that in some cases we had to breathe on them for the scanners to detect them as being real. The best outcomes were achieved by extracting the latent fingerprints with the camera phone, electronically enhancing the picture of the fingerprints with an oriented Gabber filter implemented in Python, offset producing a transparency, utilizing the transparency as a mold and molding it in a liquid latex. Using this method, the optical sensors were simple to trick. The rubber gloves and fingerprint ink method also functioned with capacitive and ultrasonic detectors. Conclusion: utilizing fingerprint analysis or synthesis techniques, attackers can quickly produce a huge amount of spoofs. Additional evidence from this experiment support the critical need for anti-spoofing methods for fingerprint identification devices, particularly for smartphones that are widely used for payments and cell phone unlocking. It should be mentioned that the present scheme does not work on all the phones. The suggested method might not be effective for the newest cell phone types as smartphone makers create improved anti-spoofing algorithms. Nevertheless, it won't be long until attackers create more effective hacking techniques not only for fingerprints but also other biometric characteristics used in smartphones. Local verifications is becoming more crucial as the use of smartphones to view internet accounts and conduct in-person transaction grows. In addition to being more convenient than using passwords and usernames, fingerprint identification methods are also getting more and more popular. As fingerprint recognition technology develops, so does the potential to spoof smartphone detectors by creating false fingerprints photos. Phone manufacturers are now including strong biometric anti-spoofing technologies in their layouts to reduce the risk, and customers are increasingly favoring these safeguarded gadgets. Thank you, and we are ready to answer if there are any kind of questions.